How many of you knows that Hack&Roll has a hardware batch for this year's Hack&Roll? Okay, I mean, it's somewhat obvious given the title of this talk, but yeah, so guess that was interesting. So, hi everyone. Just as a brief introduction to myself, I'm Terence, and he's Yik Jin. We are both NUS computer engineering students, and we are the key batch makers of this year's Hack&Roll hardware batch. So, just as some context, uh, I like to call this like a mission of mine, because personally, I'm part of NUS Grey Hats, and 10 years ago, NUS hackers, people from NUS hackers have helped NUS Grey Hats make the first ever NUS hardware badge. So, so as you see on the badge over here, I do have some, but I guess I can show them later. So this is the GreyCTF badge from 2016. This was actually made by someone from NUS Hackers. He helped NUS Grey Hats like made this badge for one of our cybersecurity competitions. And 10 years later, you see we have Hack&Roll hardware badge. Yay! 10 years in the making. Minor clapping ensues. Okay, so just as a brief outline of how the talk is going to be like, so I'm just going to go through about like basically the rough background of like both electronic badges and like how this project came to be, some of the ideation process, the schematic process, the coming out with the artwork, as well as some parts of the prototyping process. Afterwards, it's mainly handling things like the firmware, NFC tagging system, assembly, and operations on the Hack&Roll itself. Okay, so let's begin. So, how many of you have interacted with hardware electronic badges before? Just a quick show of hands. Okay, I guess not a lot of people. That's fine, because I guess electronic badges are still quite a they are still quite a rarity for a lot of people to see. Now, these are some of them. So these are some of the electronic badges from various events, both in Singapore and around Singapore. So I guess one example is that you can see there's a badge that is a GitHub logo. I'm not sure if you can see my mouse. You all can see my mouse cursor, yeah. So this is actually something they issue to, I think, everyone who attended like GitHub Universe, which is one of the tech conferences in, I think it's in America. And the idea is that these kind of badges, they have screens, they have like some fancy blinky LEDs. They just blink, they look cool. Sometimes you can just hack them and you can personalize them to your own liking. Those kind of things, yeah. So for myself, I'm part of NUS Grey Hats, and generally, I've been making some of these PCB badges for a while for NUS events. Some examples, I guess, maybe if you're in the cybersecurity scene, you all have seen like some of these cat badges. So there's one here, and there's another here. And so these are made for our recent GreyCTF 2024 and 2025 events. Yeah. So I think at one point, since badge life was starting to become a resurgence in NUS events, given the badges I made, I was discussing with Yik Jin about like the idea of a Hack&Roll badge. And the idea is that maybe it's a cool hardware project that we can do, and Hack&Roll is an event that we can bring this kind of hardware hacking badge live at scale. Hacking in terms of like the NUS hacker spirit, yeah. And then anything for sparkling and click things. Click, sparkle, yes, them. And afterwards, with some discussion with JLo, we decided to get it on board. Given my past experience with batch life, I figured that even though the timeline seemed a fair bit of short, I think it started in around October, and we had about 4 months till January. I figured that we could probably try to get something to work, and to get it work consistently with iterations and with enough testing to be confident that it will work. Yeah. So I guess there's some rough timelines of it. I'll just briefly skim through this, which is that we mainly did some ideation, prototypes, and then afterwards tested everything, assembled everything, and then come for Hack&Roll. So the overall timeline took about, I think, 14 weeks or so. I can't remember exactly, but it's still about like 3 to 4 months. Okay, so let's start from the beginning, which is the ideation. So there were three main goals we were looking forwards for this concept of this hack and roll hardware badge. So the reason why we wanted hack and roll hardware badges, which the first reason is like sparkly, clicky, clicky things. Hardware badges are cool, so I think it makes sense of why they are cool. Most events you just get like a piece of paper showing that, oh, I attended this event, but having something that blinks, having something that's interactive, I think is more fun. But more importantly, for a case such as hack and roll, we use them to actually track food collection status and like other forms of engagement. So most notably, if you've been to a hack and roll before, usually when you collect food from the various buffet lines, in the past, you'll see that they will scan your tag with a tag which has a QR code, and we wanted to replace that with an electronic badge and potentially improve the UX. And since we've gone all the effort and gone all the way to incorporate fancy electronics to the badge, we might as well make it hackable and to like improve the level of hardware hacks within hack and roll. So we did some cost considerations and analysis, and we eventually decided on the ESP32, mainly because first it has Wi-Fi, so you can connect it to all sorts of different things. It's Wi-Fi and Bluetooth. You can connect the badges together. You can deal with things like the Internet of Things. It supports simple to use frameworks like Arduino and more, I guess for the case we are more focused on, MicroPython, so that it's easy to get started hacking the badge within a short period of a hackathon. And of course, Expressive has been rather active in sponsoring student clubs. So yeah, so this is one of the considerations that we are thinking about too. And some other features we are looking towards the badge itself was that generally it should have some LEDs, some buttons, and since we have some space, we could fit in a buzzer for quite cheap. For batteries, we eventually settled on AAA batteries, mainly because they were easy to procure and give out at a scale without handling, for example, logistics issues or any risk issues with rechargeable batteries. At one point, we were deciding for an OLED, but eventually, due to cost considerations, we decided to cut it. But I think with the spirit of hack and roll, this decision also came with like other benefits. For example, it forces people. I like to think that it forces people to be more creative in how they use the badge itself. You have to use the LEDs to deliver some functionality and explain like the badge and explain the menus and draw letters, draw faces, draw all sorts of different things. So it partly encourages creativity, and that was something I really liked when I was working on the firmware for this badge. And as for the tracking system, we mainly wanted to get it because the hack and roll tracking system was rather stable in the sense that I myself am a participant for hack and roll for a few years already, for about 2 years, and then I volunteered for 1 year. The system is rather stable and rather easy to set up and get going. And it's a QR code based system, so you'll generally like use a phone to scan the QR code of a participant. At least the volunteer will use a phone to scan the QR code of a participant to track attendance. And this was something that we thought we could replicate on the scale with an electronic badge with the help of our production partners such as JLC PCB. With JLC PCB, there's an option that we can set when ordering these badges such that every PCB that is ordered will have a unique QR code with a unique number. So if you all happen to have the hack and roll badge and you all look at the bottom, this is the unique QR code and this is the unique number, and we use that as a way to like generate uniquely and use it for the hack and roll web app. But that said, we're also looking towards other areas such as, for example, RFID or NFC, because with RFID or NFC, you can just tap and go. You don't have to go through the effort of like making sure the lighting works super well for a QR code, or making sure that your camera can focus in on the badge and other things like that. So we are still exploring, but mainly QR code and potentially NFC. Now on to the schematics.
Okay, so for schematics, so I'll be going through this section because I did most of the schematics for the hardware badge over here. So you can see here a brief overview of the hardware badge schematic, right? It's divided into a few like groups. So there's power management, there's connectors, there's like the microcontroller unit, yada yada yada. So for power, right, you can see that the power we actually, if you look at the badge itself, you can see that there's a USB-C port as well here and batteries as well. So that's like 2 power sources, right? So we actually have a power selector switch, which is this black switch over here. You can see if you all have the badge with you, like, so this is the switch itself that corresponds to this this schematic element itself. So this is the switches between the USB power and like battery source power. We needed a boost for the battery, even though there's like 2 like AAA batteries, right? So by right this should be 3 volts, but the ESP32C3, if I'm not mistaken, it accepts 3 volts minimum to like 3.6 volts. So the moment like the battery start to deplete, then the voltage will start dropping. So because it's quite sensitive with regards to like the input voltage that it requires, we needed a boost converter over here. Then for the USB itself, we also had a ESD protection with this ESD protection IC chip over here you see on the right. So that's just to prevent like any like sudden like spikes of like electricity coming from like the USB connector, causing it to damage the batch. So this ESD protection thing will like make sure that doesn't happen to the batch. So on to the main part, right? So this is the MCU. So as we mentioned just now, the MCU is this microcontroller unit, right? So we have used the ESP32C3, so that's the element on the left. So you can see we actually like connected it to like all the pins and like expose a lot of them to via different pads. So over on the right, you can see here is IO expander. So we needed an IO expander because the C3 it's quite limited in like the number of pins really, as you can see. Then we also needed some pins for example connecting via USB or like some like lights, that kind of stuff. Then like by the time you start to want to connect everything, right, you very quickly run out of IO ports. So we need an IO expander. You can see on the right we use the AW like 9523 if I'm not wrong. Yeah. So that's what you see over on the IO expander over here. That's what we connected with LEDs and the buttons. So you can see that's in the red box. Then over on the right over here, these are all the passive components that you can see here as well. So one fun fact you can see is that you can see like these buttons, right? So these 4 buttons over here are the D-pad, the directional pad button, so up, down, left, right. There's also like 2 empty slots that we used to have 2 additional buttons, which is the A and B button, because we wanted to emulate a console that was supposed to go on this patch as well. But due to lack of space and we don't want to like disrupt the art as well, because the art is like so beautiful, right? Don't just like lay out anyhow. So we decided to remove it. It also helps to save some cost as well, but not that much. Yeah, so these are the 10 LEDs. Then like you can see, this is the reset button and like the buzzer. So the buzzer is very straightforward to connect. Just connect it straight to the IO pin. That's it. So finally, we have the connectors on this batch. So connectors are basically these little. So connectors are things like you see this USB-C connector port or like those exposed pads that you see. Yeah. So we have like a few connectors. So you can see over here. One of the more important ones is the SAO connector. So the SAO connector, SAO connector thing is this one over here, the black rectangular box you see in front of the badge. So that's so you can see the pinout for this is over on the right. So you might ask what's SAO, what does SAO stand for? Yeah, you can read it yourself. I'm not gonna say the name, but like it came from like, if I'm not wrong, it came from like some DevCon like from Hacker Day. So a few Hacker Day people decided to come together to make a standard so that people can hack on their hardware badges easier, like across different hardware badges. So yeah, it's an unofficial standard, I can say. So we decided to follow that as well. Yep, so you can see SAOs, with SAOs, right, so now that there's an unofficial standard, people can very easily create their own SAO badges with like the specified pinouts you saw on the previous slide. So one example is what Terence is holding onto here. So yeah, so you can design your own PCBs with the SAO pins, then just attach it to the badge itself. Then it will work because all SAOs are the same, ideally. Yeah.
So I did. So I had a hand in the SAO in deciding that the connector should be an SAO because I thought it would be fun that not only you can just bring home a badge, but if you ever go overseas to like this kind of to like similar hacker conferences or things like DevCon, Hacker Day, or open source, and they have SAOs, yes, you can use your Hack&Roll badge to power these SAOs. Yeah, so I thought that would be nice. Okay, so now for the art. So we were brainstorming about what the art of the badge should be, and we had a few ideas. So Yik Jin had the idea of a Tamagotchi, and I had the idea of like, what if you can have the badge be Quacker's head, and then and then you connect it to other things, and then you have Quackers hacking your laptop. A lot of different ideas. But given the theme of this hack and roll, which is, I guess you can tell, is like Dungeons and Dragons D20 dice, we eventually settled on Quackers rolling a dice. So you can see this is some concept art that I roughly drew up. So you can see that Quackers is generally holding a dice in various different ways, and then you can see how and then you can see like Quackers holding in different ways, how the two badges can connect together, other different aspects, so on and so forth. And afterwards, I think our artist Yang Xiao, she she came out with this first draft of the artwork, which is actually, if you notice, the artwork that is used on the back of like the Hack and Roll volunteer shirt. However, it wasn't used for the badge because mainly due to space constraints. If you notice that at the back of this artwork, this is a AAA battery holder. It simply would not fit on the badge. It simply would not fit on the badge, even if you stack the components. And so this was less than ideal. And I decided that maybe I asked her, maybe you can like redraw the artwork to give us more space to play with. And then she, of course, started cooking hard. And by cooking hard, I mean come out with the final design of the badge. So the leftmost design is actually what she first suggested, and then afterwards she made the eyes bigger, and then she adjusted some of the proportions. And yeah, so this is the design you see on most of the hack and roll hardware badges. Yeah. And then of course the right one is like some coloring I asked her to give so that we can like have a sensing if we want to do color for our badge. So now all the prototypes. Since we have the artwork, the first step in converting an artwork to a prototype is first you have to import it in. You have to like get the outline of the badge, and then afterwards import it into your PCB design software like KiCad. In this case, we use mainly KiCad, and then afterwards we figure out where the components will go. So we got the rough outline of the board. We added the artwork. We laid out some components. Decided that hey, since the big dice is so empty, we can fit LEDs on it. Since there's space at the side, we can maybe fit an SAO port there instead. And then we can put buttons on one of the other dice so that maybe like one dice could have like one thing to play with. And then the topmost cube will have the USB port and so on and so forth. Another general theme is trying to balance like aesthetic sense with practical sense. The practical sensibilities is that you need to keep like components which are related close together. So power related components such as the USB, the voltage regulator, and the battery circuitry are all concentrated near the top, I guess as you see on the image, the top right of the badge. And then afterwards near the power is the ESP32 microcontroller. And then afterwards you have space to like lay everything out and play with it. After layout, the next step is routing of the components. This case went rather easily, given that this batch was rather doable. And I think when I was in Shanghai at that point, and I just like spent like 10 p.m. to like I guess here they say it's 2:34 a.m. just looking at the PCB design software, just drawing wires, connecting everything together, and then it passed. It worked. I put JLo's face on it because I could. Yes. And then afterwards, sent it for production. So the batch arrived. Then afterwards, I think about 2 weeks later, when I'm back in Singapore, the batch arrived. JLo's face was printed on it very well. The buzzer works. It runs MicroPython. The LEDs work, and everything seems like it will work. So great job! Yay! That's the first prototype. Now on to the second, unfortunately. So, but before that, just as a side tangent. So one of the inspirations behind this badge is this little village that I visited in DEF CON called the ICS village. By little, I don't mean it's little. I mean it's actually quite big. So for context, in an overseas conference, they usually have these kind of electronic badges, and they will sell these kind of electronic badges. And this electronic badge is for industrial control systems. So basically things like power plants, water production plants, or water filtration plants, and so on and so forth. And this was the electronic badge that they had in mind. This was the electronic badge that came out. So you notice, where's the art? Where's the art, guys? So it turns out that this was because they had a misunderstanding with the supplier, and so it didn't come with the art that was needed to. And so what they had was a very creative solution. Color my own badge. So you can see, so I have one of these here. You can actually take markers and you can like draw on your own badge. And if you're guessing where this is going, it's because we copied from them. We copied from the best guys. So our first prototype was fully white. We were thinking about exploring color printing. But I think since I had this idea in the back of my head, I went to Popular, just grabbed some markers, and then I quickly color my badge, and oh, the markers actually stick. And then you can see there's actually some potential. For example, every badge in Hack&Roll will be unique. It will be uniquely colored. So if you just think about that, that's actually quite a huge potential. And of course, the other hidden ulterior motive is that it will save cost and engineering effort. But no, ignore that. It's actually to make everyone's badge unique. Guys, please trust us. Okay, but back on working towards the second prototype, since we had our base functionality working, we could add on additional functionality such as NFC. So for our NFC functionality, we mainly like looked through our supplier online and like looked for the cheapest possible NFC chip that we could implement the most easily on the badge. And that led us to this component called the NT3H21111 whatever. It's an NXP chip, and it's basically like an NFC tag. But there are some other intricacies you do when implementing this kind of chips. Is that first you need to generate antenna, and I guess for this chip, in this case, it can be powered by the NFC reader. And also, I guess a fun fact about this chip is that it has I2C support. That means you can actually communicate with it through other microcontrollers or devices, such as the ESP32 on your badge, for example. But back on the main track, I guess, we implemented NFC antenna through a script that we found online. Generally, this kind of scripts involve like doing some calculations, some RF calculations to find like the inductance, find like the ideal coil length, and then after cross-checking all of those math in the script manually, we just try to make sure that there are no other electronic components near it, such that it will cause any issues. This is also the main reason why we didn't have space for extra buttons, because we needed to free up this big space such that it's a easily available NFC spot. And then there are also some other features we tried to improve, such as, for example, the battery connector. We tried to edit the battery connector and make it like easier to handle, or at least there was an effort. We tried to improve like the credits and the QR code. For example, to avoid any lawsuits from JLo, we remove his face, and instead we replaced it with this very nice looking, I like to say, QR code and credits scheme along with our logo for our sponsor, Expressive. Yay! And then afterwards, we also had pads for hackability that for the more advanced users, they can actually solder to them and like explore more functionality of their badge. So things like UART pins, extra GPIO pins, and like extra IO expander pins. So in case AI tells you, these are not capacitive touch. These are not capacitive touch. Don't blindly trust AI, guys. And afterwards, we got it. It somehow turned out to be a one-shot, one-kill. The NFC worked perfectly, or almost perfectly. The non-perfect part was that our phone sucked. And then it looks good. The LEDs work, the buttons work, everything works, and then we are ready to order 1,150 pieces, or actually more like 1,149 pieces. So as a quick fun fact, if you're wondering why the credits was done in such a way, it's because at one point we were thinking about like what we wanted to name the badge, because we thought like, if you call it like just a hack and roll hardware badge, it will just be like super boring, you know. Badges should have cool names, like, I don't know, DEFCON Cat badge or something like that. And I had some idea, and then I think hackers and I had some ideas, and so one of the highest port names was like Quack and Roll, and the next highest port name was King Quackers, the Mallet Wizard. But I guess like with every few good things, you have the urge to combine them together to make something even better. So, given a suggestion from one of my friends, we decided to do a light novel title. So, in case you didn't know, as per the official badge itself, the full name is called Quack and Roll, King Quackers the Mallet Wizard of King Gizzard and the Lizard Wizard. So it has about, I don't know how many words, but this is the official name. Quack and Roll, King Quackers, the Mallet Wizard of King Gizzard and the Lizard Wizard. Hack and Roll 2026 badge. And as like every good light novel title, you shorten it to the Quack and Roll badge. Yeah. And given that the PCB is done and we managed to order like in bulk, we still had a few other things to go for. So one of them is like the firmware that people will play with. We had two aspects that we needed to do. So one of them is the ESP IDF library, and we needed a library so that people can easily interface with the buttons and the LEDs of the badge. And because given our expensive sponsor agreement, they wanted a workshop that uses the badge itself, and they thought it would be cool. So yeah, so we just did that. But for the majority of the participants who didn't exactly wanted to interact or hack with the badge, I thought it would be nice to at least still give them a functionality to engage with the badge somewhat, or at least be like, oh, it looks cool, and there's actually some blinking in my badge instead of just being an empty circuit board. So one of my main considerations I tried to do was to implement somewhat decent UX on the badge, and yes, there's UI in the badge, guys. And one of the considerations is that you have 4 buttons, you have 10 LEDs. If you're a participant and you're asking someone or like how do I use the badge, it'll be like, what button do I press? What do I go to? I made it such that you just press one button to change between the LED blinking modes. So that's one of the considerations I had to try to make the badge simpler to use. The other buttons are just for fun. Don't need to care about them if you are not feeling like it. Yeah. And eventually we also had 8 different modes. So these are some of the LED blinking modes. Some of the face modes were given by suggestion of various sponsors and friends. Yes, like one of the dice modes. Yeah. So there's music on the badge also because we have a buzzer, so might as well include music. So the music is formatted in RTTL, which is this specific like Nokia music format. And so it's actually from the old Nokia phones. Yeah. And so I have some class code for that for Python, and I try to incorporate them. And yes, if you notice on the badge has like songs from the Hack and Roll 2026 promotional video. So you can literally like scroll through Instagram, find the song, play it on the badge. I am not joking. I actually tried to transcribe most of them by hand. And of course, since we had space, and I didn't know what other songs to put, I think just from the promotional material, we had like 6 songs. I, of course, just put J-Lo speaking inside there. Because I could, yes. Yes. Yeah, you're part of the music, guys. So, a lot of people have asked me what these pads are actually meant for. So they are meant for expandability, but another idea we had was batch-to-batch comms. So as for how batch-to-batch comms would do, here you go. So you just tap. So given that if you could tap the badges behind, such as in this manner, you have 3 points of contact with the badge, between the badges, and hopefully you can do like some simple communications. At least that was the rough idea I had. But unfortunately, due to various circumstances, these contact pads didn't really work well. For one, the schematic was thought of rather last minute, but eventually also decided that it didn't really support strong communications. For example, you didn't have pull-up resistors. You used the IO expander pins, which fundamentally meant that you can't do this on a hardware level. You need to bit bang it in software or emulate it in software. And I spent 2 days on this, and I just like gave up. I don't think it was really worth it. And so I moved on to the next best and more reliable thing, which anyway better represented what the sponsor wanted. Bluetooth. So the Bluetooth was quite stable. We used the AIOBLE library in MicroPython. There's a TLDR of this is that one batch decides to be a server, one batch decides to be a client, and they connect together, and then they send data from one batch to another batch to communicate between each other. So yeah, we had batch-to-batch comms, but given this hardware batch, you may be wondering why we wanted to have batch-to-batch comms, and that was because we wanted more people to engage with the batch and wanted it to be more fun in a way. So one of the ideas was to maybe have like a simple dice roll game, where two batches can connect to each other and like roll the dice together. So yes, you can do that. And this is the rough way it works. Yeah. In the interest of time, I'll just skim through this. Another idea I had for batch-to-batch comms was for sponsors, for like sponsor engagement, because this was something that was tried off in other places in the world where you use badges for sponsor engagement. Unfortunately, we didn't implement it on the actual Hack&Roll itself due to time constraints, but I did try to implement sample code, and I did get the functionality working on the final batch. It's just that given the engagement sponsors were having, it didn't make sense to use badges as another form of engagement. Sponsors were already answering questions from participants. So I don't think they needed too much more engagement from something that was troublesome to set up. Yeah.
Okay, then we're moving on to the NFC tagging PCBs. So like you guys received for participants of Hack&Roll 2026, you all received this main PCB, right? But actually, when you all collected food, you all realize that there's another PCB, which is this small black one that I'm holding on right now. So this is the NFC tagging PCB. So I'll be going through more on this. So one of the goals that we decide on why we decided to make this NFC PCB in the first place is because yeah, I can see so mainly because I want to try PCB routing also lah. Then also so these are a very nice excuse. Then also because we wanted to have ease of usage with the NFC system. Like we could use a phone, but the problem is that you need an Android phone to be able to do it, because I think iOS, Apple, like they don't really support it, especially via a web app that we use internally lah. So we decided to go with an external solution like this. And it also kind of makes sense to use NFC to track, like, for example, food collection statuses, because, well, we already have a hardware PCB batch. We already have a hardware batch, which is this, right? So with hardware batch, there's like, you can stuff in more electronic stuff on it. You can do digital stuff. So like, why not just use NFC instead of like just like previous years, like QR code, you know? Yep. So this is a very brief NFC, like the brief NFC rundown for the flow, right? So if you realize, right, this batch, we use a lot of like off-the-shelf, actually we mainly use off-the-shelf modules. So this red one is the NFC module that's available everywhere. It's like the most common NFC module is the PN532. Then you see the rest, the OLEDs, the buttons, they're all like, yeah, packaged, like ready to use like packages. So honestly, the main reason for this is because like what Terence said, NFC was like a bit rushed, like it was a bit of a last minute addition. So we were a bit pressed for time also. So in the interest of time, right, we just like used the modules that we could find online, and then we just like stuff it all together on the PCB, then very easily just wire them all together. So if you see on the images on the right, you can see like it's mostly on the PCB, it's mostly all just like the modules plus like you can see a few resistors, like some SMD resistors, THD resistors, yeah, breadboard buttons, that kind of stuff. There's not much like other components that we have to solder on ourselves or whatever. Yeah. So the main purpose of this batch is to basically scan the NFC tag that is present on the participant's like white badge over here. So you can see here the NFC. If you have your own badge, right, the NFC is this squarish thing that was the coil that was generated by the Python script that Terence did, that Terence used, sorry. Yeah, so this black badge will tap on this NFC coil thing to be able to interact and scan the NFC tag of the participant's badge. And then it will send an API call to the Hack&Roll server to say, okay, so this participant ID has actually collected food at this time for this for breakfast or for lunch or for dinner. Yeah, so we mainly use this because we needed to track food metrics so that we can better plan future iterations of Hack&Roll. So a very brief rundown of the schematics. You can see, like what I mentioned just now, we use a lot of off-the-shelf components. So it's literally just plomp, 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 and then you just wire all them all together. Then maybe a few like pull-up resistors. Then that's about it. Yeah. So the NFCs and the NFC and the ESP32 that we use, right, which is this one, is the Seed Studio CL ESP32 C3 also. So they communicate via I2C. You can see the I2C that we wired. We didn't even wire the interrupt line because there's no use for it. It's literally just you scan it. We are not like waiting for an event to happen. So we just didn't wire the interrupt lines. So these are the modules that we obtained, all from Shopee. So so they all came pretty quickly, and then we could like very quickly just like solder on like about 20 of these badges that we had, 20 of these PCBs that we ordered. So it was a pretty quick job. And one side note is that my THT resistors got cancelled from Shopee because the seller failed to ship. I don't know why, because THT resistors are so common everywhere. So I had to go Sydney Tower just to buy it. So yeah, whatever. So at the end of the hackathon, right, so we actually gave out these badges to like people who basically colored their badges the best. So we reprogrammed it with the bare bones firmware that you can see on the screen over here. So all participants, all the winners of the hardware coloring badge, right, hardware badge coloring actually went home with this loaded in to this NFC tagging badge, which is just I colored my badge and all I got was this lousy PCB, which is quite funny, I think.
This was inspired by last year's Crackers Commendation Award, which was a towel saying, I won Hack&Roll, but all I got was this lousy towel. Yeah. And I thought, might as well keep the tradition going,
Yep, so as with every rush job, there's always a bunch of issues that crop up. So this is of course no exception. So we initially selected CircuitPython because this Seed Studio CL ESP32 C3 board supports CircuitPython. So like, whoa, cool, let's just use CircuitPython because Python is so much easier to use than C. So we used it. It worked well for NFC tagging, so we actually used the CircuitPython code to like tag all of the participants like white badges. So yeah, it was like 1,200 of them we have to like tag with this black board. So yeah, so that went well, and then until I decided to also code in the food scanning feature. So with food scanning feature, you will need Wi-Fi, right? Because you need the Wi-Fi to be able to upload data to like the Hack&Roll 2026 server. Yeah, and then the moment I tried to do that, CircuitPython ran out of memory. Wonderful. So it very frequently crashes. It doesn't even go past like the menu itself. So it just hangs there, and then you got to press the reset button, wait 3 minutes for the MCU to like come out of its panic state, and then to unhang itself, and then it's gonna crash in the next 5 seconds. So I was like, whoa, cool. Then at that point it was like 4 AM for me because I was like working through the night for this. Then I was like, then I just asked, I asked Terence who worked together with Le Yu. So you can see in the chat, Le Yu is the one who was like mainly debugging all the code issues. So yeah, it turns out that because we used the latest version of CircuitPython, CircuitPython 10, then CircuitPython 10 wasn't exactly optimized. So we switched back to CircuitPython 9, and suddenly all our issues were gone. As you can see, it's what Le Yu said on the picture below. So it's like, yeah, it's extremely frustrating. So lesson learned was to just not use CircuitPython for me.
I'll say that is to try to understand your tools, and if they fail too often, just quickly move on. I don't think there were goods and bads with using CircuitPython, but yeah. I think I'll just go on. Yeah. I guess some other rough things is that this was something we call a Le Yu codex moment. CircuitPython didn't support WAPA2 Enterprise, so it couldn't connect to school Wi-Fi. And guess what? All you just needed was codecs. You just threw the whole CircuitPython firmware in codecs, and it automatically solved the problem in like, I don't know, like 4 hours. So use AI, guys. like any other responsible tech CEO would say.
Yes.
Okay, so now that we've gotten our base of our tech our tech up, which is that first we had our PCBs, we had them like somehow almost ordered. We had our NFC firmware, NFC board, NFC firmware, and our main batch firmware. It's time to put it all into action. You know, we needed to like get it assembled, get it ordered. So our final order was for 1,149 PCB badges. So given that we have expensive sponsorship, we could use consignment. So Expensive sent the ESP32C3s directly to JLC PCB warehouse, which then assembled them. And we also have like spare empty PCBs because you can order PCBs you need to order PCBs in like units of certain quantities, but you cannot choose to assemble some of them, and you can use to assemble a specific number of them. Some other things that we got like AAA batteries from Shopee, color markers from like running out popular things here. Lanyards, I'm not too sure who got it, but whoever got it did a good job. Did a very good job. And I ordered battery holders from Taobao. So yeah, my mother complained that why do I have 11 cartons in my home? And then I'm sorry, mom. But then here's the thing. I ordered the battery holders. Turns out I can't plug them into the badge. So that automatically means that you have to prepare 1,149 battery holders and solder them to the badge directly. So here's what I like to say as an analogy. So this is a typical RISC-V CPU as taught in NUS computer engineering lectures. So we are learning from the best because, of course, Expressive uses RISC-V, NUS uses RISC-V, and guess one thing they do is pipelining. And we like to treat our batch assembly as a pipelining process. And more specifically, adding one more stage to make it better, a 6-stage pipeline with people working on all 6 stages. And so one thing is that first you have to get the badges, you have to like depanelize them, which is to remove the excess. Afterwards, you need to prepare the battery holders. You need to like cut off the connectors, strip the wires, make sure you have the metal parts accessed. Afterwards, you solder them manually on all the battery holders. So imagine like basically a sweatshop of people like just opening those 11 cartons, just unwrapping the battery holders, just all their life is to do is just snap out the PCBs, and then afterwards solder, and then solder like some, like what I guess other people will say like some Chinese sweatshop. And then afterwards, you're not done. You still need to like tag the NFC such that it works with your system. You need to program the batch firmware, and then you still need to like assemble everything such that people think like your batch is a coherent product and not like something that's about to fall apart, you know. But yeah, afterwards you got Wingstop, so it's all worth it. So NFC tagging wise, we needed a more predictable and more reliable way to like do the NFC. So one thing is that we used a QR code NFC linking system. We used the phone to scan the QR code on the badge, and then afterwards, that data is sent to a computer, which sends to the NFC board, and then afterwards, it's then used to write the data onto the NFC tag. Shout out to, I guess, JLo, River, Yik Jin on working on all of this. And then programming-wise, it turned out to be rather fast, but given that you have 1,000 plus badges to work on, you still need to find a way to automate this. And so the dream is that all you do is take a badge, plug into your computer. Once it lights up, unplug it out. Prepare a script that does this at scale, and that can do badges that can program multiple badges on a single computer in parallel. And there you go, you have a production line ready. Just plug in, plug out, plug in, plug out for 1,000 badges. It's just 1,000, guys. Yeah. So pipelining. So we got the badges assembled. We got them working. Or I like to think that we got them working. And now they are sitting in like 3 big boxes in RC4, and Hack&Roll is tomorrow. So now we actually got to get ready. Okay. And I guess like but before that we still had to like handle ESP IDF workshop, and that was the first time we tested a batch, and that worked mostly well. Right, and then we also needed to test like our rough NFC system. But I guess the main 3 areas that I was focused on the flow is that we needed to distribute the badges like on registration and figure out if like 1,000 badges fail or whether 1,000 badges had no complaints by the participants. And thankfully, I think it went well. I wasn't overwhelmed with complaints. And then afterwards, because of the unique NFC tagging system, we needed to be aware of like of the food collection timings and how food collection was handled. And then, of course, since I had a great idea of a badge coloring contest, I also needed to have a hand in that and like have a hand in that, yes, and look out for good colored badges. So yeah, operations, I guess as a whole, they went rather smoothly. There weren't any big catastrophic failures like lines of people queuing up. Why doesn't my badge work? Thank goodness. I like to think it shows that people tried the badges and they work instead of people not trying the badges at all. Yeah. Unfortunately, this is also where some bigger issues showed up. So some hardware issues, for example, we miswired the schematic such that it doesn't support dimming the LEDs, for example, or that our battery solution actually doesn't support enough power to do things like wireless communications, or at least substantial wireless communications. And yeah, so these were some things that were raised up during the event. So personally, as a computer engineering student, I had the smart idea of taking electromagnetism. And I thought, hey, this is NFC. It's electromagnetic waves. I should be able to do this, right? Guess what? Guess what? I put a Faraday cage on my electromagnetic components. So if you notice, so right below the NFC board is literally a flat metal surface shielding radio waves. So how am I able to like easily tag my badges? So the downside is that instead of like a normal NFC reader, I can put it a certain distance away. I have to like tab it right at a very specific spot and get it working super well. As someone who taken electromagnetism. But I guess something more interesting is that, oh hey fine, maybe I'll change the position of the NFC module. Guess what? The NFC interferes with the Wi-Fi. So the Wi-Fi is now slower. So I guess this is something that is quite interesting to me because generally you look at modules like electromagnetism, you see, oh, you do the math and it's like, oh, of course it's going to reverse. Then you do it in real life, it's like, you do it in real life and you make like these mistakes and then you like, oh, you made these obvious mistakes, you shift it in a certain way. Guess what? Some magic causes something to break. So I guess that was quite fun to notice on like the actual day itself. And another thing is that we had very significant Wi-Fi issues with school Wi-Fi. So after our fabled Leu managed to do codecs and get CircuitPython running on NUS school Wi-Fi, then on the actual day itself, it all just started failing. So guess that was quite sad. And then we needed to adapt fast, so we fell back to scanning the badges with QR codes, scanning the badges QR codes with phones. For some cases, since we still wanted to validate the NFC, we can use a mobile phone hotspot. But we actually eventually figured out that we can't use iOS hotspots, so we had to do coordination to figure out like maybe this pair will have Android hotspots to like handle the NFC, and then we have like 4 pairs stationed around the 4 booths, and then you can see how this quickly gets messy. But I think in the end it was still rather worth it. We did test the NFC, we did find some issues, but in the end, actually, I think NFC has certain level of potential for future food collection. So I guess this is one example. For breakfast, we didn't have a lot of people basically awake to do food scanning. But with this NFC board, I could just leave it there and ask the participants to scan it. I could do more of a role where I can just supervise and tell them to scan and like look out for other people, or like for example they ask me where can I take the utensils. So this is a way that I can see potential in like freeing up manpower to do other things. Though there are some UI UX issues to be optimized along the way. So I'll say the NFC was rather interesting on the actual day itself. Okay, so overall, Overall, I tried to collect some metrics, and generally, I'll say that it's a success. Most notably, after asking around, we are actually one of the largest batch life related events in Singapore. Our largest competition, or at least one I heard so far, is literally ourselves, NUS GreyCTF, which gives out about 300 badges to participants. But I guess more interesting are the numbers of people who engage with the badge. And I am very pleased to say that I've seen a fair bit of engagement. Just around the hackathon itself, you can see like people coloring the badges, and you can see people who did badge hacks. And I guess even more surprising, you see not just one, but two teams who hacked on the badge and won hack and roll with the badge. And I think that's actually quite amazing. And these are some of the coloring we've done with the badge, which I think is also actually quite amazing. Some of the artwork they do, like for example, the one on the top left, she literally traced the PCB lines. Yeah. And then here are some other badges. And some of the hacks they did was quite interesting. So I intentionally exposed some of the NFC pads, and guess what? One of the winning teams tried to incorporate NFC into their project. And then they had to do some quite fascinating engineering, in my opinion. And another thing is that I guess it was a good decision to keep it as a surprise, given like the outcome. And I guess good job on Quackers for keeping it a surprise till the end of, till like Hack and Roll itself, and not spilling the batch plans along with spilling Hack and Roll, the Hack and Roll event itself. Yes. So here are some credits. Just briefly go through. Just to briefly say, so me, Yik Jin, Le Yu, Yang Xiao for art, Raven, Darren, everyone at NUS Hackers basically. Yeah. And thanks for especially sponsorship, and as well as NUS Hackers for allowing us to make this a reality. And thanks for listening. Yeah.
Yeah, so if you want to take a look at the schematics of this, right, this entire badge is actually open source, so you can just scan the QR code over there. You can get both these badges schematics and the NFC scanner. They are both open source available on this repo. So if you want, you can scan, you can play around with it. Yeah, then unfortunately, we don't have time for Q&A today, so if you want to ask us questions, right, you can actually come down during Hackerspace. You can keep a lookout on the NUS Hackers Telegram group. We'll be posting a post about Hackerspace soon. So you can come down during Hackerspace. It's Wednesdays, 3 p.m. to 5 p.m. on some weeks. So just keep a lookout on the Telegram group, yeah? Thanks.
I guess if for anyone who's interested in like electronic badges and hardware badges, y'all can just find me some time during the pizza, and I can feel free to share some more with you. And in fact, as a token of appreciation, we have a lot of empty PCBs available here. So please do come up, take one of them. Yeah, empty PCBs, which represent our badges. Yes. I think it would be nice to take one of them and see one for yourself. And just as another promotional material, so tomorrow there's actually another batch life related event. It's hosted by D0. If you are interested in that, y'all can also attend that. And yeah, thank you for listening.